Today we are going to go towards the next step of cluster analysis. So that day we discussed that whenever we want to classify objects into some group, or whenever we want to create some clusters, we are going to need some sort of quantification of how to measure the similarity or dissimilarity between two objects. Correct. So for that, of course, what we need is distance function. So do you remember, you might have studied in real analysis different types of distance function. So does anyone remember properties or at least names of some distance functions? Maybe you might have learned it with the name metric spaces, metric in your ST101 course. Hello? Is my question clear? See, today my internet connection is very unstable, so you have to at least tell me whether you heard me. Yes, ma'am. Okay, fine. Yeah. So, do you remember distance functions or metric spaces, the concept of metric from your ST101 course? Yeah. Okay, so can you give me at least names of couple of common distance functions? Euclidean distance. Correct. Euclidean distance. Sorry? Gaussian distance. Okay. Okay. First, let's talk about Euclidean distance. So, how do you compute Euclidean distance in univariate setup? Anyone? It doesn't have to be Pushkar. Okay, anyone is fine. How do you compute Euclidean distance in the univariate setup? Shortest distance between 2 points, so straight line would do the job. In univariate setup, straight line would do the job. But I mean, I want formula. You're right, it is shortest distance, so straight line. But what is the formula in univariate setup? If I have say 2 points x and y, what would be Euclidean distance between them? X and y are two numbers because I'm talking of real line. So what will be the distance between them? On a univariate case, it would be x2 minus x1. I don't have x2, x1. I talked about x and y. You should answer in my notations. I did not say I have x2 and x1. I have. Correct? Yes, tell me. If x is less than y, then what happens? Yes. Yes. So if x is less than y, then what happens? Hello? Hello? Are you able to hear me? Hello, ma'am. Your audio is missing. Okay. Okay. So can you hear me now? Yes, ma'am. Okay. So if x is less than y, then what would be the formula for Euclidean distance? Y minus x. Okay, so in general, how would be the, in general, what would be the formula? Mod of y minus x. Correct, correct. Mod of x minus y. And in a bivariate or multivariate setup, what would it be? In bivariate or multivariate setup, what would the formula be? Considering y1 is less than y2 and x1 is less than x2, would be y2 minus y1 whole square plus x2 minus x1 whole square to the power of y2. Do you need them to be less? Whatever you said, y1 should be less than y2 and x1 should be less than x2. Do you really need that? Not necessary. It's already squared, so it's not necessary. Correct. So you don't need any of that. You just need x1, x2, y1, y2 to be the two coordinates, and then you can say x1 minus x2 square, y1 minus y2 square. Okay. Yeah. So Euclidean distance. What about others? Now, what are the properties of distance function? So, have you studied properties of distance function? So, what were the properties of distance function? What were the properties of distance function that you have studied? Can someone list the properties? It will non-negative. Okay, the first property is distance function should be non-negative. Okay, then
Distance xy is equal to distance yx.
okay, let me try to write down. So first is, wow, distance xy should be greater than or equal to 0. Then distance xy should be equal to distance yx. Okay. Anything else?
Distance xy equals to 0 if x equals to y.
Okay, distance xy thing equal to 0 if x is equal to y. Okay, then
Distance of xy is lesser than distance of x comma z plus distance of z comma y.
okay, distance xy is less than equal to xz plus zy. Okay, okay. Now this first property we will call as non-negativity, correct? First property we call as non-negativity. Next property we call as symmetry, because we are saying distance xy is same as distance yx, so we call it as symmetry. This we will call as reflexivity, although part of it is still remaining, and this we call as triangle inequality, correct? Okay. Now one more thing here. You told me distance xy is 0 if x is equal to y. Do I need to add something here? Do I need to add something here?
Ma'am, can it be an equivalence condition? Like it is also possible that it is converse can be true.
Correct. So this is actually if and only if. Okay. Distance xy is 0 if and only if x is equal to y. Is it okay? So these are 4 properties of distance function, but we are still lacking at the basic step. In general, when we say something is a distance function, what is the domain and codomain? What is the domain and codomain for a distance function? Yes. What is domain and codomain for a distance function?
And the domain would depend on the space that we are working in. Like if it is a univariate case, then it would be simply R, and
Correct.
codomain would be R itself.
Your domain would be just R or something else. Others can also pitch in. See how my like whenever we are writing D, what are we writing in the bracket? X comma Y. So what would be the domain? Let me give you a hint. Can I say, okay, what is the distance of Pune? Would this question be sensible? Simply saying what is the distance of Pune.
Okay, ma'am, it would be R cross R, right?
Correct. Correct. So, for defining distance, you first need two things. You can't define distance unless you have two things. So, in general, we start with let S be some set of objects. S be something is wrong with my laptop. So, S be some set of objects. Basically, it is set of those objects on which we have to find a distance, or between or among which we have to find a distance. Then you define distance function as a function from S cross S to R. Okay, or you can say only the positive part of R union 0. Okay, in general, if I define on R, it doesn't matter, codomain can be R, but this has to be S cross S. Okay, because distance is a bivariate function. You need two arguments as input, and then only you can compute distance.
Hello, ma'am, your voice is breaking.
Okay. The stability of internet connection is actually an issue. So up to what point could you hear me? Actually, I've kept my phone in the window in a hope to get better range. Okay. Is it slightly better now? Okay. So I have kept my phone in the window and with window open, so I hope that should work. Okay. So we always have distance function defined on S cross S. So we need two objects between which we define the distance, and it will be your codomain can be R also, that is fine. Okay, codomain can be R, you don't have to specify. So this is important. Distance function is defined on this, and then we have those four properties that you have to have reflexivity, that is distance x y is 0 if and only if x should be equal to y. Then you have symmetry, that is distance x y should be equal to distance y x. Then you have non-negativity, distance x y greater than or equal to 0, and triangle inequality. Why the name triangle inequality? Why the name of this property is triangle inequality?
3 points are involved, so triangle is naturally formed.
Okay. And does it connect to some property of triangle? Does this get connected to some?
The ratio of any kind of triangle,
Hmm?
the
one side, that is xy, is less than or equal to addition of lengths of the other two sides, that is xz and zy. Okay, hence the name triangle inequality. Okay, now so these are the properties that any distance function should have. We saw one example, Euclidean distance. So in bivariate case also it will be a straight line. In trivariate or fourvariate or in general p-variate case also it will be an equivalent of line in that direction. Okay, in that plane, sorry, in that dimension. So now any other distance function that you have heard of? Any other distance function that you are aware of? Yes. Other than Euclidean distance, you have not heard of any other distance? And now someone other than Pushkar, because he told Euclidean. Am I audible?
Yes.
Have you heard this word? I mean, in the context of distance function, you must have heard as a place in US. I don't want that. As a context of distance function, have you heard this word? Manhattan. So, what is Manhattan distance in general? So, in bivariate case, if I go, I have a point here, and suppose I have another point here. Euclidean distance will say, okay, let's go along a straight line. Assume that this is a straight line. So Euclidean distance is a straight line distance, but Manhattan distance is not a straight line distance. Manhattan distance will be go horizontally, then go vertically, or vice versa. Go vertically and then horizontally. So basically, Manhattan distance is like how rook travels in chess. Okay, so it can be computed only at 90-degree angles. Okay, whereas Euclidean distance is like in any direction. Okay, it can be computed in any direction. So it's like me. You can move in any direction. So Manhattan distance is also known as city block distance or a taxi cab distance. Okay, it is known as city block distance or taxi cab distance. Why city block? Because generally, if you assume that you have a city which has roads only at 90 degrees, then this is how you will have to travel between two places. So you can't travel like this because the road structure is something like this. Okay, so you can't travel diagonally or something like that. So in that case, if you want to reach from here to here, then you have to go this way first and then this way, or this way first and this way. So this will be hence called as city block distance or taxi cab distance. So you can't, I mean, again the same assumption that you need a proper road for a taxi. Okay. So what would be the formula in the bivariate case? Then we generalize. In the bivariate case, formula will be, if I call this point as say a1 b1, I don't want to bring in x and y, it creates confusion, and then this is say a2 b2. Okay, then my formula will be mod of a1 minus a2 plus mod of b1 minus b2. Okay, mod of a1 minus a2 plus mod of b1 minus b2. This is my formula for distance between these 2 points. Let me call this as P1 and this point as P2. The distance between P1 and P2 will be this. Is it okay? So this is Manhattan distance. Then we have few more distance functions. You might have heard of Minkowski distance, correct? Minkowski distance you might have heard of. Then what else? Any other distance function that you have heard of, or the Have you heard of something called as trivial distance or 0, 1 distance? Yes, have you heard of something called as trivial distance or 0, 1 distance? Yes or no? Okay. So, this is going to be especially useful when we are going to have categorical data. So, basically what we do is we define distance between xy as 0. X and y can be any objects. X and y can be two chairs, two people, two clouds, anything. Distance between xy is defined as 0 if x is equal to y, of course, and it is defined as 1 if x is not equal to y. So we basically say that distance xy equal to 0 if x equal to y is necessary, because then otherwise your distance function definition won't be satisfied. So distance of an object from itself is definitely 0, but all the other objects we will say they are at the same distance 1. Okay, so this is known as trivial distance or 0, 1 distance. Now if you think in terms of physical distance, it might seem like what do you call a crazy definition, I mean for the lack of a better word, because you might feel that how can you have everything at the same distance, how can you have everything at distance 1? But this makes sense when you have categorical data. Okay, so I think in the last lecture I talked about fruits. So if I want to talk about fruits and suppose I have say shape of a fruit, okay, then I have say sphere or spherical shape, then oval shape, then cylindrical shape. So in such cases, if I want to say, okay, so spherical is not equal to oval, spherical is not equal to cylindrical, and I don't want to get into quantifying whether spherical and oval are close to each other or spherical and cylindrical are close to each other. Okay, so I would say that yes, spherical and oval are not equal, so I will say distance between spherical and oval is 1. Similarly, spherical and cylindrical are not equal, so distance between them is also 1. Similarly, oval and cylindrical are also not equal, so distance between them is also 1. Okay, so for me, what matters is whether they are equal or not. Okay, why? Because when I am talking about say two fruits, so let's say I am talking about mango and banana, and I want to talk about two properties, say color and shape. Now on the basis of color, I would say okay, both have yellow when they are ripe. So I will say okay, on the basis of color they are perfectly similar. So distance on the basis of color is 0. Distance on the basis of shape is 1, because this is supposed to be some sort of sphere or oval, whereas this is supposed to be cylindrical. So here distance is 1, so total distance is 0 plus 1, so 1. I want to compute distance in such a manner. Hence, for categorical data, this trivial distance or 0, 1 distance turns out to be very useful. Is it okay?
Yes.
Okay. So, remember we are always, I mean, most of the times for categorical data we'll be using this. In ordinal categorical data, sometimes you can use Manhattan distance also, because the order is important. So, for example, if we are say trying to classify, trying to yes, let's say trying to classify students on the basis of their uh, grades received in a certain subject, then we can say okay, so people who have received A grade and people who have received say B grade, then we can say that okay, people with A and B, because there is an order to grades, so we can say A, B, C. So we can say that okay, A, B is more close to each other than A, C. Why? Because there is an order. So in ordinal categorical data, sometimes you can use Manhattan distance. So here I can give the numbers 1, 2, 3. and then I can use Manhattan distance. But in nominal categorical variables, we can never use Manhattan or Euclidean distance. Okay, why? Because there is no order, so you can't convert it to numbers, and unless you convert it to numbers, you cannot compute the distance. Okay, so what we do here is we use this trivial distance or 0 1 distance. So if the things are equal, we call distance is 0. If things are unequal, we simply call it as 1. We don't bother about any other number. Is it clear why we need trivial distance or 0 1 distance?
Yes, ma'am.
Okay. Now your homework is check whether this trivial distance or 0 1 distance satisfies properties of distance function. Okay. So homework is check whether this satisfies properties of distance function. All the 4 properties. You must have done similar examples, right? Checking whether a certain function satisfies properties of distance function. Am I right? You have done such examples in 101, right? Okay, examining if a given function is a distance function or not. So that is the homework. Examine if the trivial distance function is a proper distance function or not. Okay. What are other distance functions that you have heard of?
Yes, ma'am.
I think I asked a question. What are the other distance functions that you have heard of? Am I still audible?
Yes, ma'am. You are.
Okay. So this Euclidean distance is going to be mainly used for continuous variables. Manhattan distance can be used for continuous or ordinal categorical data, and trivial distance will be used for nominal categorical data. When you have binary data, there are further issues. So when you have binary data, then you have 0 and 1 as the encoding, right? So for example, gender can be recorded as binary, or yes or no type of answer. So if I ask you people whether your graduation is from Pune University, yes or no, so it becomes a binary data, correct? So while computing distance between two binary observations, there are three possibilities. One is you simply use something similar to Manhattan distance, so 0 0 is matching, 1 1 is also matching, and if it is 0 1, then you say they are different, so they are dissimilar. But sometimes people say that in the binary setup, 0 0 match is of actually no use. Okay, 0 0 match is of no use. Why? Can you guess? Why 0 0 match is of no use? Let us say I'm talking about languages known by different people. Okay, so I'm asking everyone whether you know Marathi or not, whether you know Hindi or not, whether you know English or not, and say whether you know Kannada or not. Okay, recording 1 if the person knows that language and 0 if the person doesn't know that language. Okay. So I have this person who knows Marathi, Hindi but who doesn't know English, Kannada. Then I have another person who knows Marathi but does not know Hindi, English or Kannada. Then I have another person who does not know Marathi, does not know Hindi, does not know English, only knows Kannada. Okay. Now I am trying to compute similarity or dissimilarity between this. Now when I am doing that, if I say that okay, this is 0 0, so these people are up to some extent similar, this is 0 0, so they are similar up to some extent, then yes, they are similar up to some extent. But depending on my purpose of grouping, this 0 0 match may not be of use to me. Why? Because okay, they don't know Hindi, they don't know English. But if they don't know any common language, then this match is of no use to me. So if I consider that okay, distance between them is, so here this is mismatch, so 1. Here this is again a mismatch, so 1. So if I say the distance between them is just 2, it is not 4 or it is not 3, because these two are matching, then I'm reducing the distance. But the problem is, if I use this for cluster analysis, then sometimes people who don't know any common language might be clustered together. And if suppose my purpose of the cluster analysis is to say create some discussion groups, then if there is a person who doesn't know any language common with anyone else in that cluster, then it becomes a problem. Hence, in binary setup, sometimes 1-1 match is more crucial or more important than a 0-0 match. So 1-1 match can guarantee that okay, if I put these two people together, they can converse in Marathi. Whereas 0-0 match, so if I put say this P2 and this third person together, then it is of no use because they have no 1-1 match. The only matches are 0-0 matches. So they can't, they don't have any actual variable in common. Okay. Hence, in some cases, people feel that as far as binary variables are concerned, 1-1 match should not be given an only 1-1 match should be given importance in computing similarity or dissimilarity. 0-0 match should be ignored. It should not be treated as similar. But again, this is not a hard and fast rule. Depending on your domain, depending on your context, you have to decide whether a 0-0 match being called as similar makes sense to you or not. So now I have another homework for you. Assuming you all have soft copy of Johnson and Mitchell. Do you have? Do you have a soft copy of?
A few of us have. I'll share it in the group.
Yeah. So please share it in the group. Everyone should have soft copies of Johnson and Mitchell and Harder and Silver, both the books. So in Johnson and Mitchell, there is a table which gives binary distances. Okay, distances between binary variables. Okay. So go study that table, understand that table clearly, and given any two binary objects, you should be able to compute distance between those two objects by any of the formula given in that table. Is the question clear? Is the homework clear?
Can you please repeat?
In Johnson and Mitchell, there is a table which gives various formulas for computing distance between any two binary observations. Okay. So, your homework is to read and understand all those formulae, and then given any two binary observations, you should be able to compute distance between those observations via all those formulae.
Okay.
So basically you don't have to create anything new.